of level 1, then we increase the reliability of level 1, we merge again, and we can continue the post-processing. Now, we actually come now to the last step, I see. It's the evaluation metrics. I'm not going to show code here because it's quite straightforward, but it comes down to the things that we have right now is that, for example, we just look at area distribution for habitat classes. So at level 1, we can count the number of pixels that are classified to that level 1 class, and then we look at how many pixels do we have in the entire study area, and we create derive the proportion, or we can really go to hectares or square kilometers and so on. So this is just for our study area that we were executing. This is the output. So you can see there's quite some cropland area here. And also, I think in the previous presentation, tried to also make that link to the red list status of habitats by the IUCN. And they have certain kinds of classifications or categories. So I'm not sure. I think this is critically endangered or endangered, a critical, least concern, not threatened, and so on, and then vulnerable. And you can see in this class of vulnerable, there is quite some R21, which is the mesic permanent pasture of lowlands and mountains, which looks like this, which is quite represented in our study area. So, and then lastly, I want to say, I think when we're going in the direction of thinking about things or ways to validate the habitat map that we're going to create for Vojvodina, an independent validation data set is something definitely to consider. So it will be useful to create or derive the map accuracy instead of our model accuracy, because the model accuracy was still based on the training data input as well, because we just took a validation set from the training input. But for the independent validation data set, this is going to be extra to look at how our habitat map is, with every post-processing step and so on, is trying to predict the class for these points as well. And then also, again, showing the reference area way that we can, with a very specific and accurate validation or reference map, we can look at how do certain classes behave at borders with other classes. We can look more spatially. So that's going to be interesting too to explore if possible. So this was the tutorial. I think if there's still questions, we're going to handle them maybe after this. But this last slide is just to show where do we go from here. So this was the workshop, the online workshop. We're running up, we are in the run-up towards the visit of BIOS to VITO, which is going to be in the last week of March. And what we're doing at VITO's side is we're preparing the notebooks that we have seen snippets from in this presentation. We are working on a guidance note that I'm working out this kind of presentation version into a real journaling of the workflow and how to execute and things to consider and so on. I think it's going to be interesting to hear more of your ideas about, indeed, features, training, collection, and so on. And definitely get yourself familiar with UNIS habitat classes and which features might be interesting for the classes that are going to be mapped in this Vojvodina region. Also, since we are definitely going to use openEO, if you don't have yet an account, create that account on the CDSE platform. Try to run a bit of these notebooks that we've seen yesterday with Hans. And also, Hans still has a presentation in the afternoon. So try to follow it. This is going to be about the model inference. So it's going to guide you a little bit through some things of the notebooks that we've seen also today. And lastly, so for the visits, when you are visiting here at VITO, we will probably also try to get that mapping of the Pannonian zone as the preliminary habitat map ready then. And we will have a lot of brainstorms. I think you already heard Marcel talking about having a drink and then having a good conversation about features and so on. So we will be hopefully able to come up with some good ideas of going into the first accurate version of that Vojvodina habitat map. So
Okay.
thank you for
Thank
your
you.
attention.
Just to say you something before you just
Yeah,
go to close this session, it's very important because now, like the slide before, I just realized it was up to me that you need evaluation metrics for the map accuracy. It's and the model accuracy you're gonna validate. So that's why you ask us for the independent data set that we plan to do with the drones. So maybe one of the topic that you should cover with Peja and Branko for now is also that how to plan it, or like they are senior programmers here and they do know approach, I guess, that better than me. But then some discussion regarding it should be also done in. Yeah,
definitely. Yeah, sure, definitely. I think that's all definitely on our planning in that week that we have direct contact with each other. It's definitely going to come up. If there are any questions, I'm gonna stop sharing and then yeah, I see Marcel.
So what I only wanted to say is if the, I don't know how many persons will come to VITO, so that's Lori's ballpark, but mostly for me, if you want to run, for example, a national zonation instead of the EEA zonation, which is quite rough, let's say it like this. So if you want to work more with a zonation which is more suitable for Serbia, then please bring a vector shapefile for that, because to implement that is quite easy. So in the time we are running it here, because we have already for every S plot and for every S plot and EVA data point, we have already extracted the data. So to restructure the points in a different biome, that is that needs no time in the end. So we can theoretically directly run an adapted version for Serbia if you don't want to run it with the EE habitat biogeographic zones. The next point is if you have additional training points you know very well for a certain area, bring them, because I can run the feature extraction for that in real time. So we really need then just like maybe 1 hour or 2 hours, and next day we could run directly a mapping with your own points as addition to the EVA and splot open points, so we could directly see if we get a difference in the mapping results, if you are interested in such things.
yeah,
Think about times, because currently we are generating the models for 2024 and generating the map for 2024. So you have to make sure the training points you're bringing are representing the year 2024. Otherwise, the training points we cannot really 100% trust. Think a little bit of colors, because as you saw, Lori just put a random color scheme on the output. So if we have a list of all the UNIS habitats which can exist in Serbia, think a little bit of a color scheme, how you want to visualize it, because that is something as a programmer, I'm not really interested. I use random colors and then I'm happy. But a lot of people who are doing really nice maps, they have way more better ideas about that. And I think last but not least, the rest we see here, so we can experiment. You can also see what you can do more with the tools we have already developed, and hopefully we get a good map.
yeah. Thank you, Marcel, because by naming all the points that we should take into consideration before coming to VITO, and maybe even because of this fieldwork planning, I need to talk with Aline, maybe to add one more person to come who is more into this fieldwork than these programmers. But it's up to Aline to decide, and Lori to see if it's possible, if it's yeah.
I think for us it's possible. I think it depends on you. I think if someone wants to come, I think it's going to be interesting to have that information a bit close as well.
Because the one that I would suggest, I just realized maybe it's like it would be just better for all of us to have maybe even that person who is more involved with this fieldwork planning, and then they can cover all this topic. And yeah, it would be nice. But I let me talk with Alina. It's just like something that came out as a conclusion from this lecture you had and give us today. Yeah, thank you.
Yeah, what we could maybe even prepare is already extracting all the feature data cubes for Serbia for the year 2024 as 10 daily composites, like for example NDVI or just pure reflectance, if you want that, that already your team can have a look, or we can provide you a test data cube that you can see. I don't know if Lori has already planned that. So we have test data cubes for the 10 daily time series, reflectance and radar data. We have data cubes for NDVI time series. So theoretically, these data cubes could already be like provided so that they can have a look. And maybe you get ideas when you see it, or following up ideas, what you want to do with the data, or what you could do with the data. Yeah, that's something we can discuss.
Okay, thank you.
Okay. Thanks, Marcel, too, for joining the session. It's has been really valuable to have you two here. Yeah, so I'm not sure if there are questions. I see time-wise that we should take our lunch break now, so we can start in time with Hans. Like I said yesterday, when Maya asked about all the links and the PowerPoints, they are going to be compiled, and you will get this information then soon. And also then, if you still want to ask or send a message to Marcel or Hans or anyone, you will be able to. So maybe let's take the lunch break now. Then we can come back at 1:30, and we have that last session of Hans. Okay?
Okay, thank you.
Okay, thanks a lot for listening and your attention. Okay, see you at 1:30. Okay, bye. Hello, everyone. Welcome back to the workshop. Maybe raise the hands if you're there already, just to get an idea if we are again, if everyone is present again. Okay. So maybe for some people that are joining again, please raise your hand if you are being there, because I cannot really see you guys. So it's nice to know if we are again with the entire group that joined. Okay, I'm just already going to introduce that next session. So first of all, yesterday we had a full day with Hans about openEO, getting started, introduction, and so on, and also this exercise, which was hands-on, and I think was also interesting to learn to see what kind of snippets of code you can use to generate your own processing line in a bit. So first of all, in the first 5 minutes, Hans is just going to give again a little bit of an overview of what take-home lessons or lessons learned from yesterday, and maybe some extra tips and advice that he can give you for when coding in openEO. So then he's also going to introduce how some of your own codes can, like we did with the habitat mapping workflow, how that can be kind of converged back to or like in openEO, and how you can optimize processes. And an example of that is going to be applied for the model inference part. So we've seen in the presentation that I gave in the previous session how the model inference is part of our habitat mapping process. Now we are going to look a bit deeper into the code of the inference. So we mostly showed what is this wrapper around openEO to run the code in the blocks and in the different modules. But in this next session, Hans is going to show you a bit more in depth how this is applied in openEO. Okay, I see some people are still in the lobby, so okay, maybe Hans, if you're there, you can take over and start with your last session.
Yeah, perfect. Thank you for the brief introduction, Lori. So that being said, I'll first start with a small recap of yesterday and provide some context on what I'm going to present today, the notebooks, where they actually fit in the larger workflow. So let me share my screen. So yesterday was all focused on learning you on how, as a new entry user, you can start playing around with openEO. So we saw, and maybe I can go back on the slides, that we have some different concepts we should know. openEO is a cloud backend agnostic layer, which can be used to access data on different backends, and can be used to process this data. And for this habitat workflow, we've been mainly focusing on the CDSE backend, the Copernicus backend. On the Copernicus backend, and we've seen that there are quite a lot of useful tools to use there in this bigger ecosystem. So we had a small hands-on exercise which would simulate a new entry user starting to work with openEO. And what tools did we there promote to use? Well, mainly to rely on the broader community to learn how to actually work with openEO. So we have a big community which can add their own community examples to the openEO community examples repository. We mainly work in the Python one, where we have a large collection of community examples, and we do our best to also indicate which openEO processes are used within this community example, and this really serves as an inspiration to kind of get a kickstart or an easy way to get into your project, to think, hey, what do I actually want to do in my project? Okay, I want to do something with machine learning, for instance. Then I see here, oh, okay, running ONNX models. Okay, this could be a useful notebook to check. Maybe I simply want to calculate NDVI or another index. I want to calculate indices based on Sentinel-1. Okay, I can read here through the table and I see we have an example here which showcases how to perform SAR backscatter and compute indices. This might be interesting and might be able to kickstart my own research. And here I see another use case example which also contains a couple of indices. So there are quite a lot of notebook examples here which you can rely upon to get easily started with your own project by providing some tools from which you can copy paste and try to get it to work. Now, if you want more information on how it actually works, we have the official documentation on openeo.org. And on openeo.org, we also show these basic steps again, basic authentication, how can it be done. We showcase how you can create one of these data cubes, how you can apply operations on the data cubes, how you would execute a batch job, and it also has some full examples of typical workflows. So we have these different, we have the notebooks, we have the standard documentation and user documentation, and all you can read through in order to get inspired on how to work with openEO. Now, of course, it may be that you start working and something doesn't work. And the difficulty with openEO is that, well, the complexity is that we work in a cloud-based environment. And typically you're used to launching your jobs, launching your work on your own laptop, and you can very easily get access to the error messages and you fully understand what's going on. Now we work in a remote computer with remote dependencies, and it's sometimes harder for new entry users to fully understand why is my workflow not working. And the CDSE has a very nice resource for that. It's this CDSE web editor. Let's see if I can log in to give some live example. First need to drag this away. So let's find the relevant link. There we go. So once you have your CDSE account, you can log in. And this web editor is really, I think I constantly have it open in the second screen. Let's log in. So what does this web editor offer? Well, the main reason why I use it is you get a full history of, I think, for a couple of months of the openEO jobs which we have launched. And we can see their status. We can sort them by status. We can see which jobs were finished, which were, for instance, in error. And if you have a job in which you were interested, we can take a look. We can see how costly was it. It costed X amount of credits. We can see how long did the calculation take. We can take a look again at the process graph to remember what was I doing again in this job. So that's mainly the standard information. You also get a job ID. This is typically something you need to give to us, the core team, if you have an issue you can't resolve yourself, then we'll ask after the job ID of the job you launched. Then we can dig it. Then we ourselves can start digging as well in the job logs. Speaking of these job logs, if you press the small bug, we find all the logs of these jobs. From these logs, we can then distill, are there any error messages? Are there any warning messages? So if your job failed and you go to these job logs, you can call them up. Now it's taking a bit of time, but once you have them, we can filter out what the warning messages are, what the error messages are, and we can get some more information on what went wrong. So for instance, we see here a warning, might be relevant. Then we can take a closer look at what this message actually tells us. So this is a really nice tool, this web editor. So I really recommend to actively use it. I can see if I have here somewhere an error in this job, which I can also find the logs from if it's not too old. Let's see if that loads in. While it loads in, also the CDSC has very big document, really a lot of documentation, which can help you, again, kickstart working with openEO as well. So you have the documentation portal, which also gives information on how to create an account. It gives information on what data CDSC here offers. It offers information on the APIs, being also one of them openEO, but it also offers information about, for instance, this openEO web editor, which is one of the applications, so you can read through it to fully understand its full capacity. Apart from that, if you go to the page portal, you go to support, you also see there's a community forum. So if you launch some openEO jobs and they're not working, what can you do? Well, you can contact us. So if you log in, you can create a new ticket, you can ask a question, and then if you ask your question here on the forum, we see here, for instance, a user who didn't know how to access Simple 5LP, and then once we see this message, we start to respond to the user on how to resolve their issue. So that's also a very valuable resource to know. Here, for instance, finally on this web editor, if we have an error in this job, we can also figure out what was the actual error, where did it get wrong. And if you don't understand this error and you don't recognize it, then simply contact us, because we try to resolve this issue then for you. So those are the main tools I want to showcase. We have the documentation and we have the community examples. You have the web browser, which is a very valuable asset for yourself to keep track of all your openEO jobs and also figure out what went wrong. And then we have the forum. If you don't understand the error or you want some more information on a specific openEO process, just ask us and we will reach back out to you. And then we focused a bit for the starting exercise on this Getting Started notebook, which gives the standard steps for an openEO process, which we also here showcase in the slide on how do we typically work with openEO. We authenticate, we load a collection of our interest, we apply some processes to it to build up this so-called process graph. Once we have the process graph, we can execute a batch job, let it run, and download our output results. And this is what these process graphs could look like. Now, what do we want to discuss today? Well, you had an introduction about the habitat mapping workflows, which are built upon openEO. And the core idea is that we don't only make you familiar with these habitat workflows, but that you also understand the openEO technology on which they were built. That way, if something goes wrong on your end, you might already know where the crux of the issue might be, and you can give us more detailed information on where we can assist you. So if I think of this project, and I'll go to presentation slide, of all the large projects which we have been supporting, for one of which is the World Ecosystem Extend Dynamics project, which is very relevant to the habitat mapping workflows, we see a very common way of working. We see that you first as a user want to do mass data extraction. Then you want to perform your model training. This is for now, until now, still typically done offline. But once you have your trained model and you have your data extraction pipeline, well, you actually want to combine them. And you're doing a similar data extraction, you want to spool in your model in order to perform model inference. And if you then done this on a very small patch or a small country and you validated your output, you will actually want to upscale this and create large land, continental, or world scale maps. Now, where is typically openEO used here? Well, for the data extraction, model inference, and for the upscaling activity. And the upscaling is quite seamless, since if you build your tools properly in the data extraction in openEO and for the model inference, upscaling is one of the things in which openEO makes it easy for you by simply repeating your process over a larger extent. Now, yesterday, we also already took a look at one of the more advanced examples on this data extraction. There we took a look at this multi-backend job manager community example, where we showcased, okay, assume you're not only interested in one small area of interest, but you want to collect data over 9 small patches or 9 areas of interest. What type of openEO tooling can you use? Should you launch 9 individual openEO jobs? Well, no, you don't have to. We rely on this job manager to do it for us. And I think today you've also seen that within the Habitat program, or the NCA team has also built tooling around this multi-backend job manager to actually make it more seamless for you and make it more understandable on where is the data extraction happening and are these jobs successful, yes or no. So this was one of the first, the first more advanced workflow which we presented, or advanced tooling we presented. Now, this is one piece of the larger puzzle. So if you build in openEO your data extraction pipeline and you have your model, then you want to do model inference to create your large-scale maps. Creating these large-scale maps is something, again, you could do with this multi-backend job manager. But the question now remains, how can you bring your own machine learning code into openEO? And we can pull this even broader. It doesn't stop with, it's not specific for it's not specific for model inference. It can also be that you want to do some statistical analysis with some dedicated statistical package. And that you want to integrate this workflow within your openEO pipeline for analyzing the large amount of data. Well, this is something which we can do through the concept of UDFs. And UDFs are user-defined functions. So today, I want to guide you through this principle of UDFs. And I want to guide you through this principle of UDFs. If you're interested in the subject and later on you want to know more about it or read more about it, well, if you go to openeo.org, one of these platforms we recommend for getting your information, you see that we have even a specific section here on where you can find the official documentation on the openEO UDFs. This is the Python client documentation. And here you can see how UDFs operate in the openEO Python client. And it gives a very broad, but also very technical look on how you can use them and so forth. And what are all the possibilities on what you can do within openEO. Now, we realize that this can be overwhelming for new entry users. So that's why we also created a dedicated use case example on the usage of UDFs, specifically tuned for model inference. So that's one I want to go through today. But before I start, are there already any questions or comments? Maybe something someone wants to have reiterated before we start on this UDF subject?
Is perhaps UDF covered in those in that MOOC?
So in the MOOC, the MOOC is really the basic tutorials, and the MOOC more focuses on standardized openEO processes. So this is, again, a very insightful question. Remember in the previous session, we had openEO standard processes for temporal aggregation, spatial aggregation, resampling, and so forth. And these are standardized processes which are embedded within openEO. The MOOC focuses on those. Now, it can be that you have a workflow and you think, wait, I can't build my desired pipeline with only these integrated processes alone. I need something special, I need something dedicated. And this is often the case when you work with machine learning or when you're pushing the boundaries of science and working beyond the state of the art. And then you're going further than what the standard packages offer. And that's what UDFs allow you to do, is really to bring your own code into openEO. So the MOOC doesn't cover it. That's why we also have a couple of community examples to showcase you how it can be done.
Okay.
So I'll jump in this first example, and if time permits, we can also take a look at a non-machine learning example. So let's talk through this one. We'll recognize again quite a lot of standard steps. Now, before we start, this is going to focus on using a CNN network, a convolutional neural network within openEO. We do a lot of vision processing, and often you want super resolution networks, you want maybe classification networks or other types of networks. So CNNs are I think, or classification can also be a cat boost or a random forest model. So these are very typical examples. And you'll see us often refer to an ONNX model. Now, this raises first a very important point on what might be necessary if you want to bring your own code in openEO. If you have your own Python environment and you're working with your code, you need to install your own packages, the packages which you want to use. If you want to use NumPy, you do a conda install NumPy or you do a pip install NumPy. If you want to use PyTorch for a neural network learning, you need to install it through conda or pip. Now, openEO works in a cloud-based environment. Remember yesterday I compared it with, there's a big computer in Poland and we say, please do some work for me, I'll log in there. Now what happens? If you send in your openEO job, so you send, please do this with openEO, then it gets sent to the big computer in Poland. And then it waits until it has capacity and it starts processing your job. Now, what's very different to working in your local environment and in a cloud-based environment, and might take some time for you to get used to, is package management and dependency management. Because this cloud-based computer doesn't have the same Python environment as you have on your local PC. It doesn't know that you, for instance, on your local machine, pre-installed PyTorch, yes or no. So we need to install additional packages in this cloud-based environment in order to work. Now, for the specific example of machine learning is a very fast-moving field of application. And we often see a lot of new standardized or new preferred packages coming up. It started with, I think, Café. Then we had, after Café came, I think, TensorFlow, Keras, PyTorch. And what we don't do in openEO is make all these packages as a standard available on this cloud-based computer. What we prefer to do is to work with the openEO format. So all the popular packages, PyTorch, Keras, and so forth, have functionality to transform your model to the openEO format. And openEO format is a specific format dedicated for model sharing. So it's something external to VITO. It was developed by Meta. And the core principle of openEO is if you transform your model to openEO, you can easily share it with other researchers without having the trouble of all this package management. And it can be easily deployed also on a lot of different systems, on mobile phones, on cloud-based PCs, on local PCs, even on your smartwatch. So you'll see us use in this specific example openEO for those who are not familiar with it. And we've also included a small tutorial, if you're interested in trying it out, on how you, for instance, can convert your model to openEO, but that's a bit out of scope of this session today.
One question related to this. From your experience, is it like straightforward, this transformation to openEO, or like does it depend on the complexity of model or something?
If you're using standardized networks like ResNet, CNN, then it's very easy and very intuitive. I think the main issue with openEO which we face or we see is if you're doing something very experimental in your model architecture, then it might be that openEO has not caught on yet on the type of model layers which you're using. So in these cases, when we see we can't convert it to openEO, we often help with these users to simply use PyTorch, instead. So remember, this is fully possible as well to use PyTorch, but we need to maintain all the packages used for openEO. So that's why we try to centralize this and make our own life easy and your life easy by focusing on this openEO architecture. But if it's not possible to use openEO and you need TensorFlow or you need PyTorch or so forth, we can also accommodate it, but it will take a bit more time and probably a bit of collaboration between the VITO team and your team, while openEO should be able to work seamlessly without our help. So for CatBoost, Random Forest, ResNet, standard CNNs, it's all possible. If you're going to transformer-based models and pulling the latest one of Hugging Face and trying to deploy it remotely, then I think you might run into an issue, and it's best to get in contact with us that we can help you onboard your model on openEO.
Okay, thanks.
So we see some similar steps, and I'll walk through them again. First, we authenticate. Here once more, we see that we're going to use our Copernicus backend. And we start to build up our process graph. And first, we build the first block on loading our collection. In this case, we're loading in one band of Sentinel-2 data. We're not going to cloud mask it. We want to run our model on all pixels, even on clouded pixels, but we do only take time steps for which we don't have a high cloud cover. So what happens here is our backend will look for all possible. So we provide our spatial extent and our temporal extent. When we load this collection, openEO will search for all valuable observations within this time frame, within the spatial extent for Sentinel-2 LA. By here already providing a max cloud cover, we will check within your area of interest, is the max cloud cover lower than 20 or higher than 20. If it's higher than 20, we skip this time step and we remove it. So this is a first rough filtering to limit the amount of data which we're reading in, but we'll still have clouded pixels in our observation. But the total amount of cloud in our area of interest will be lower than 20%. So we built this initial data cube, or S2 cube, and we want to run our machine learning model on this observation. Now, if we want to use our machine learning model, openEO needs to be able to access it. Remember, openEO will work on this remote cloud-based infrastructure. So in order for openEO to be able to reach your model, it needs to be accessible. So in this case, we put our model in a public storage. You see the model here. Test ONNX model was zipped and was uploaded to a public repository or a public accessible storage, in this case Artifactory, but this could also simply be publicly available Google Drive. Now, because the cloud-based computer, this big computer in Poland, doesn't have ONNX stored saved as a standard, what we did, ONNX installed as a standard, what we did with the openEO team is we created additional dependencies to be installed. And these are dependencies we maintain for you. So if they need an update, we update them ourselves, such that they will always remain valuable. So we have these two URLs, the model URL and the dependency URL, and we need to give them with our openEO job in order to inform our cloud-based PC, please download this model and make it available, and please download these dependencies and make them available. We also
one question, just interrupting you. These dependencies are not made by us during transformation to an NX model, no?
No. So if you will transform to ONNX, these dependencies should be fine for you. We try to maintain them to keep track with the latest ONNX version.
Okay.
So this is a standard folder which you can use. If it doesn't work, get in contact with us, and again, we can see if they need an update. But so we try to take away the difficulty for you in terms of dependency management of the cloud-based system. And we know which Python version is installed, we know which X-ray version is installed, which NumPy array is installed. And for all these packages, we need to be really cautious that when you add these ONNX dependencies to use ONNX or PyTorch or TensorFlow, that actually these packages are able to work together. From openEO side, we want to take this difficulty away from you, and that's why we now provide some standardized packages for often requested machine learning frameworks. So we have one for ONNX, and I believe we also have one for PyTorch.
And are those dependencies related only to the model, because model will be encapsulated in a separate environment, or those are dependencies for the whole platform?
So thank you again for the insightful question. So when you send in an openEO job, you rent a very small piece of a PC, remote computer, which has some pre-installed packages. This dependency folder, which we create, ensures that our ONNX version and the additional packages which we needed are compatible with the pre-installed packages on your cloud-based PC. So if you add them, you don't run into any issue. So it's decoupled, I think, from the model which you want to use if you use ONNX. But for instance, it might be that you want to use a new experimental, let's say, vision transformer, which is only available in a specific Git branch or a non-released package or whatever of the latest PyTorch development. You're doing something really cutting edge. well, then it's best to contact us, because then we will try to create for you a dependency folder for this very experimental network, which is able to seamlessly be integrated with the cloud-based packages which are pre-installed.
Okay, and one more question. Then essentially, those dependencies, I mean, I can install some set of dependencies even if I'm not using any AI model, right? So those are technically two separate things, but usually they go together.
Usually they go together. So if you use a package, let's say that you want to do some statistical analysis, and there's a nice Python package for it, which is not pre-installed in openEO, then you're indeed able to install these as well. You can do this. We can check it out later on as well. You can even install this from within the UDF. That's some new functionality. Or we can build this dependency folder to standardize it a bit and make sure that other users can benefit from it as well. So indeed, it's not machine learning related. It's whenever you try to do something new or you want to use dedicated packages within the UDF, then of course you need to ensure that these packages are first installed on our cloud-based backend. But I'll showcase, I think we'll have sufficient time. I'll showcase a nice functionality of openEO UDFs, on which you can get started with as well, which works well for very small packages. So what we'll do now is we have a model and we have a dependency URL. And now we want to run our machine learning model on our cube. So how do we do this? Well, we do this by defining a UDF. So what do we do in this UDF? Well, first, there's some automation. Okay. I'll first go to the UDF and then go into a bit of details. So you see we're here now using openEO. We always simply advise people just get started from this use case example, because it already includes a bit of optimization. So we've added a couple of functionalities and we've added quite some information for new entry users on what actually these different functions do. But in theory, you can wipe it all clean and you can simply put in your own code as well. So the main important part is if you create a UDF is that you define this apply data cube functionality. And in the way that openEO works is if you have a UDF, it will take your current openEO cube before your UDF. So think about these process graphs. You might have an input data cube. Then you have a next step on running your UDF, and then you have your output cube. Well, this input cube gets translated into a popular X-ray data format, and our output again gets written to an openEO compatible X-ray data array format. So within this UDF, you can just act as if your data cube is an X-ray data cube. So we know in our community example, I might open a second window because we'll jump in between the notebook and this code. So we know we started with our Sentinel-2 cube. It's on this cube that we want to perform our machine learning, we want to run our machine learning inference. So once we reach in our process graph this UDF, the Sentinel-2 cube becomes a standard X-ray data cube. And here you'll see that we first do some pre-processing in this apply data cube. We say, well, all the none values should be filled to 0 because our machine learning network might not be able to work with nones. That can be the case. And then we have some functionality. Here we've split it up. You don't need to split it up, but where we actually run our model inference. So what we do when we run our model inference is we say, well, here's our model, test.openEO, test model.openEO. This is the model which is which was saved in a zip file, which I showed earlier. We ensure that our input X-ray is transposed in the direction for which we train our model. So we ensure that it's bands YX. We need to do this because openEO, when they say, okay, I arrive at this UDF, it transposes the X-ray cube in a standardized way. I believe it's YX bands. So here we want our data in a different format. So we transpose it in the way for which we actually trained the model. Then we convert it here, in this case, to a NumPy array, and we run our ONNX session to get the output values. Output run. And simply what we then still need to do is we build again an output X-ray data cube containing our model inference output. And that's what we do within this UDF. So once you define this UDF, which needs to contain this apply data cube functionality, then we can run it over our model, over our area of interest. And we do this through an apply function. So we've written this onix_udf.py. Now you can simply reuse this onix_udf.py function file yourself as well by simply slightly tuning it and changing it so it properly works for you, your own UDF. So what I personally typically do is on my local machine, I convert my machine learning PyTorch model to ONNX, and I try to see, can I get this here working locally? So I run my openEO job, I get my inbox data cube, so I simply download the Sentinel-2 data. I say, okay, I download it as a netcdf, I open it as an X-ray data array. What are now the next steps I need to do to run my inference? I test this locally, so I notice, okay, I'll first transpose my data, I'll reshape, I'll get this NumPy input in this case, and I run my inference. And once I have this working locally, I simply try to write it down within this apply data cube functionality and copy paste it in the UDF, and then I try to get it to work on a cloud-based environment. How do you try to do it in a cloud-based environment? Well, openEO has a couple of functions, apply and apply neighborhood. And for the CNN, we'll focus on apply neighborhood. Remember from our presentation that we have some standard openEO functionality I'll just zoom in, to apply processes across our data cube. Data cube apply. And in the standard way, you can use it, for instance, to get pixel-wise absolute values, but you can also apply, for instance, a kernel, where we shift a kernel across our data for smoothing. This functionality, apply neighborhood, is not very different from that. If we want to use this apply here, come back to the example. For the CNN network, the CNN is a convolutional neural network where a square window is shifted across your input data and convolved at every spot. And we do simply the same here. We say, please apply our UDF functionality. We give it an input size of 224 by 224. This is the input size needed for a machine learning network. It takes in chunks of 224 by 224, for instance. We shift it over our data, and each time use an overlap of 16. Now, if these things sound unfamiliar for you, this is really specific to CNN type of network, so I won't go in too much depth on how you need to set these settings. If you work with CNN networks, you'll probably recognize these values for the size of your kernel and the overlap of your kernel. Now, for now, we've told openEO, please run our udf.py, which contains our apply data cube functionality. But we still need to tell it where is our model and where are our dependencies. And we had these different URLs already. So that's something you can do with openEO. When you execute your batch job, you can provide job options. And if you want more information on these job options, you can simply browse for them. You should get an early hit on Copernicus website, job configuration. And you see there are quite a lot of options you can work with. And on our official documentation, we also provide some information on various settings. And the one we'll take a look at today are these UDF dependency archive settings. And as you can see, we also provide quite a lot of detailed information on how you can set them and how you can use them on the official documentation. So if you now go back to our example, notice what do we do? Well, we give the URL of our dependencies and of our model. And you see here this hashtag onyxDeps and hashtag onyxModel occurring. What does this mean? Well, what openEO will do for you if you pass this public URL, it will unzip it in its cloud-based environment and make it available in the following folder, onyxDeps. It will also unzip this model file and make it available in the folder onyx_models. Now, if you take a look back at our code here, our UDF, we see here that we import this onyxDeps folder and then we import Onyx runtime as ORT. So how this actually works? Well, when we launch this openEO job and we pass these job options, we tell openEO, please unzip this dependency folder and make it available on a cloud-based PC under the folder name onyxDeps. We do the same for onyxModel. Then in our UDF, we say, well, make sure that this folder is added to our path such that we can now import Onyx runtime, because Onyx runtime was one of the packages in this model dependency folder. If you want more information on how this exactly works, I will again refer you to our official documentation, but later on we'll also see a bit of a simplified example on how you can easily start going for non-machine learning workflows. And then we run our openEO job and we get our output. So before I head into the second example, I realize we touched upon some more advanced subjects here already. Does this already raise some questions, comments?
Maybe one question jumping further, like in terms of costs, is the UDF way more costly than like standard procedures that you were showing? And can we anyhow assess the amount of tokens we would need for a process?
Yeah. So the standardized functions, which we have written ourselves on our GeoTrellis backend, are really fine-tuned and really optimized to lower the processing cost. So if you use a standard, let's say you have the option to do your aggregate temporal. You can do this with the standard openEO function, or you can actually write a UDF that does that for you. So if you compare these two options, the one made available through standard openEO has already been quite optimized. The one in the UDF will be less efficient. So if you have your entire workflow and you want to port it to openEO, we see this UDF as a last resort. So we often motivate researchers on trying to translate their workflow in basic openEO processes which already exist. And if you then see something is really lacking, for instance, for machine learning inference, let's rely only then on the UDF. Because this UDF, we do our best to make it optimal, but it's not as optimized on our Scala backend code, which we provide to users as well. Now, how do you analyze this and get a sense of this job cost? What we usually need to do is some benchmarking. So we need to start on a very small scale and analyze cost, and then increase the size and get some more input. Then we realize that this can also be that you need some dedicated openEO knowledge in order to do that. And what might be already interesting to jump to is that if you have an ESA project, there's this new application propagation environment project, Apex, from which you can request resources. And so if all of this sounds interesting, but it sounds complicated, what you can actually do is you can request people from my team to do it for you. So you see here we have this algorithm upscaling service. You can do an ESA request to say, hey, I would like to have my code translated to openEO, and I want to make it efficient through upscaling or to algorithm enhancement. And then outside of your project funding, you can ask for additional funding for a week, 2 weeks of support from someone of my team. We'll closely look at your workflow, try to propagate it to openEO, and then optimize it as well for your area of interest or where you want to use it. So this optimization, often we recommend get in touch with us and we can investigate together on if we can help you right away on the spot, or if we need to request some additional ESA budget for us to take a more dedicated and closer look. If you want more information on this in the slides, I also included the Apex documentation portal. Here you find all the information on how you can request additional funding, or also some basic steps. We'll also provide some information in the future on best tools and best way for yourself to ensure that your job is as efficient as possible. So thank you for that question. I hope that somewhat answers it, that it can be complex. It requires some knowledge about openEO. So often we recommend to get in touch with us to ensure that if you're going to go to continental scale, world scale, and so forth, that first one of us takes a look and see, can we find you job options, or can we improve your workflow to really reduce the job cost?
Okay, thanks.
Then I think I'll showcase a second community example on this UDF principle. Let's maybe now take a look at a non-machine learning one. There we go. Yeah, might not be really more simple, but it's also quite relevant here. Oh, yes. So we also have a parcel delineation notebook, which also touches upon, again, using machine learning, but also using classical filtering within UDFs. So this is also one community example we often point towards. It's a bit more complex. We're actually in the process of further simplifying it, but it does give quite a lot of interesting tools for yourself to work with. So let's talk through it and go through the different steps. We see this similar pattern coming up again. We connect, in this case, once more to the Copernicus backend. We authenticate. We give a certain box of a region of interest. And as a temporal extent, we simply give a full year. And we build our initial cube. So what we see here, we load in our Sentinel-2 bands, and similar as in our getting started notebook. In this case, we load in our bands, give a spatial extent, we give a full year. We're interested in 2 bands, p.4, b.08. In this case, we're already quite severe. We say, well, within our area of interest, the max cloud cover can only be 10%. So upon loading in, we throw away quite a lot of observations of cloudy days. But then we don't want to run our processing over pixels which still contain clouds. So now we'll have some sparse clouds in our observations. Here we say we don't want to process these pixels either. So what do? We do additional cloud masking here. So we set the pixels which we detect in a cloud mask to none values. Then openEO won't process these pixels, and this is one step to make the entire algorithm a bit more computational efficient. So for this workflow, the machine learning inference will be based, the input to it will be NDVI. So we calculate once more our NDVI values. We say our red layer will be BO4, near infrared is our BO8. We calculate the NDVI values. Here you can see that we already downloaded to take a look at the observations which we have. Here we showcase 3 used time dates. 3 time dates we see they don't contain a lot of clouds. We only had max 10%. If there were pixels which still contain the cloud, then we would mask them out. And then the next step is very similar to the use case example which I showed before. We're going to run again a neural network. In this case, again a neural network. It's again a CNN network. We shift the CNN, the square box, across our area of interest. We do it in small patches of 64 by 64 pixels. And we have a very big overlap value of 32. So we shifted always half a square, and each time that our box has a 64 box, we calculate the machine learning inference. We shift it, we calculate machine learning inference. And then at the end, we combine all these results. We see that in this case, we again give some zip file which contains our actual model, and we use this Onyx dependency zip file as well. And we pass this in these job options once more. So very familiar to our previous example. Now, we can actually run this job, and we can say, oh, please run it and download our results as a netcdf file. Okay. And we can take a look, how does the output of this network now look like? Here we see that we've now done some classification. We don't get an exact binary image back, but we get an image back which highlights the parcels here in Flanders. And we can see nice split and nice difference between these parcels. However, it might be that you're not fully happy with the output of your neural network and you want to post-process it. openEO has some standard apply kernel function which you can use for smoothing, for erosion, dilation. It might be that you want to use something classical but more advanced. Then, once more, if openEO doesn't provide it as a standard, you can use a UDF. So what we'll do now is we'll post-process this output of the neural network, making use of a Sobel filter and the Felsen-Schwab algorithm. And you see it very similar. We'll dive in the UDF a bit deeper later on, but you see very similar steps once more. We have our UDF in a publicly available region, in a publicly available location. In this case, it has been uploaded to GitHub. We tell openEO, please use this UDF and run it over our image. In this case, it doesn't make sense to do this in a patched way. So we just say, well, please run it over the entire window, 2000 by 2000, and don't use any overlap. Now let's take a closer look at the implementation of this classical Sobel filter in a UDF to again get some inspiration on how you can use these UDFs. There we go. So here's our UDF function. This is very small and much easier than the machine learning one. It contains the standard applied data cube. This is the one function which you actually need to have within the udf.py file, because openEO will call this function. And what do? Well, we know we have an input data cube. In this case, that's the output of a machine learning model. And we can post-process it in whatever way we want in this UDF. You can really bring your own workflow here. So in this case, scikit-image has some very nice filters. Scikit-image is pre-installed on the openEO backend, so we can use it. So we import from scikit-image a Sobel filter. Then what we do is we get our data. So we say, well, please drop the time dimension and perform our Sobel filtering on our data. Then we can even perform additional segmentation on the output results. For this, we want to use the Felsenschwab algorithm. Is this an algorithm which we developed ourselves? No. Once more, we're using a popular algorithm provided within scikit-image. So we're using all this standardized functionality within our UDF. So these are not openEO specific processes. It can be that you did some local testing, you explored potential usage of filters, segmentation algorithms in scikit-image. You would like to use this in your cloud-based openEO workflow as well. Well, what you do is simply copy-paste your workflow into openEO, into this UDF definition, only thinking about the aspect is my input data array start as an X array. How do I now process it? And my output array should again be a valid X array, data array. But if you think about those things, you can easily integrate this in an openEO workflow. So you see here in the end, we explicitly cast our output values to an X-ray data array. We do even some more, I think here some masking, and then we give a final output cube. So this is the UDF where we are using some standard popular scikit-image functionality. And then we can take a look at the actual community example of a parcel delineation. So we had used our neural network to do some initial classification of what are parcels and what are not parcels. To give not discrete values, there's a small gradient, but we see here we have some blurry edges. Here we see some interconnections, so we can't really find the singular parcel, so we're not really happy yet with this result. Here again, we see some blurring of these edges. So can we improve this with some post-processing? Okay, we tested this out locally. We found some nice packages in scikit-learn. We think, oh, we can use this in our openEO backend as well. So let's do this. And then we write our UDF. We say, well, please, openEO, use this UDF across our data. We start again our openEO job. We see it gets a bit queued. It starts running, it's finished, and we can gaze our output. And here you can see that we tried to segment the individual parcels. The color range is now a bit difficult because there are so many parcels, so it looks like a continuous gradient, but we managed to detect individual parcels over this larger scale area. So this is again one of these examples where a UDF can be used to add specific functionality outside of openEO into your own workflow and to use it as well in the cloud. Now, what's the difficulty here, or one thing you might run into? Well, for openEX, we needed to add these additional job options, this additional package. For scikit-image, you didn't need to do that. So how do you actually know which packages are pre-installed and which are not pre-installed? Well, the easiest way might be simply try it, run it, and if you get an error message in your web editor, you'll simply see, okay, it didn't find this package. But you can always also get into contact with us Then we can point you to the resources where it's listed what the actual packages are which are pre-installed on the cloud-based backend. And then you can, for instance, locally create a Python environment which also contains these packages. And then once you have these packages installed, you can also test in that local environment your workflow, and then you know for sure that your workflow will produce the same outputs when you run it with openEO in the cloud-based backend versus your local testing. So by now I've gone through 2 of these examples. Are there any other questions here already? Yes, Franco, go ahead.
Thank you. These user-defined functions, they can only be in Python, or there are also other languages supported?
So now I focused on some examples of our openEO Python client, but we also have an R client, and you can also create your own UDF there. So if you're working on the openEO Python client, then these UDFs are in Python language. But if you're working with the openEO R client, then you can perfectly also use R code in your openEO UDF. But I think it's difficult to mix Python and R, for instance, within the same workflow.
And maybe just a follow-up question. Did you consider maybe integrating some other competing processing workflows or frameworks like Orfeo Toolbox?
Orfeo is already installed, so we actually use Orfeo on our backend for instance, our backscatter correction calculation. So Orfeo is already available.
Yeah, great.
Any other questions?
I have one question, but maybe it's too technical. Regarding those user-defined functions, what's confusing? We define those functions in our Python kernel where we are working, and then somehow we ship them to the cloud where they are executed, right? So if you have any like informations on maybe some higher level principles, how those functions are created in our environment and then executed in another environment.
Yeah, I can actually go into an example of this to showcase what's happening by looking at the process graph. It will become a bit more technical indeed. But I'll try to see if I can get it done. What I'm going to do, I'm actually going to go to the web editor, and I'm going to try to find a job where I recently used UDF. Let's see. So let's take a look at this process graph to see what I was doing here. I can use this latest job. I think I might be able to do so. Yes. Okay. Can I here zoom in? Yes. Okay. So this is actually I'm now looking at a very relevant job for habitat mapping. This is actually an openEO job which I ran for doing the model inference of the habitat workflow. Oh, maybe I can simply go to that code. That will be a bit more visual. I'll quickly need to change my environment. There we go. So I think Lori introduced you to the wheat toolbox. So I'm now in this EO processing package. This is part of the wheat ecosystem. If you go to the GitHub repo, GitHub of World Ecosystem Extend Dynamics. And you go to EO processing. There you find all the pipelines for openEO. And there are also a couple of notebooks on how to use openEO. And I have one. Here I'm looking at the notebook where I'm running multiple cat boost models. I'm doing model inference of multiple cat boost models in openEO. I think I'm running inference of 23 models here. So this is really a very advanced workflow. And if we take a look at the, you'll also recognize that when you take a look at, to the UDF itself, which is here, cat boost inference, then you see it's a bit more advanced. Again, you see some functionality for loading the actual ONNX model, for downloading the file, for pre-processing our input, but this is all simply split up to not have too much spaghetti code. In the end, what do? I have this apply data cube functionality. I pre-process my cube, and then for all the models, for these 23 models, each time I start an ONNX model, I calculate my probabilities, and I get the model output. So it's a bit the example I showed before on steroids. Now, the relevant question here was, this UDF, in this case, it's in my local environment, or it's added to GitHub. How does openEO know what I actually need to do? Well, when we invoke this, and then I'll go back to the web editor. So this is the process graph of this code. And we can take a look at the box of the UDF. So here we have quite a lot of data loading. I think here, let's see, all the way at the end, we'll do this first groups, and we'll do this apply. Okay, so when we take a look at this job, won't be able to see it from the job logs, from the web editor. I'll go into developer mode here and go to a bit more advanced logs which we typically use. There we go. Let's take a look at this job logs. So what happens when we run this UDF? We actually we translate the UDF into a JSON file, and we send this JSON file alongside with our openEO job. This is also a limitation to UDFs, so we parameterize it. I'll see if I scroll down into this workflow on steroids, and I'll find it somewhere back. So there's all data. Sorry for all the skipping, but by now you've seen this habitat workflow is quite massive in the amount of data it actually uses. So what happened here? This big block is actually my UDF code. So what openEO does is it parameterizes, or it standardizes this UDF definition, and it sends it as a text string along with the standardized openEO process to our cloud-based PC. And when it arrives there, it then transforms it kind of back to Python code. This is an important limitation to your UDFs. If you make a giant and a very big UDF and you try to do it at once in one big UDF, this total text string becomes really, really big. And you might simply hit a firewall because it became too large. So don't start writing UDFs of 10,000 of lines and send it into openEO, because then actually you'll hit a firewall. So what happens, actually it gets translated to a big text string, and it's then sent along with the openEO job, and then at our backend, our cloud-based PC translates this back, and it simply knows then what to do in this Python code. Does that somehow explain to you what happens,
Yeah,
Maxime?
clear. Thank you.
Any other question, comments, or something you're actually interested in hearing more of? Then I can maybe see if I can find a dedicated example and discuss it through with you. Then if not, I propose that here we take a small break, maybe a 5 to, let's say, 10-minute break, because I also need to fetch my laptop charger. And after the break, I'll showcase another UDF example and also talk a bit more about this Apex framework. It's a framework which you can use if you are interested in openEO and you think, hey, I want to get started with it, or I want to integrate my science code in openEO and actually use it to create a continental map or global map. So I'll introduce this concept because there we actually offer active support for optimizing your workflow, translating your workflow to openEO, and for instance, for translating your workflow into UDFs and UDPs and helping you with this exercise. So that's a bit what I'll discuss in the last hour, but I propose a small 10-minute break here. So see you all in 10 minutes then. Okay, so I think we're ready to go into the final leg of this 2-day training. Maybe we can do a quick show of hands here in the Teams chat to see if everyone's back. See. People are slowly coming in, so I'll wait a couple of minutes more. So I think as a final example, I again want to discuss one of the community examples which showcases how you can use UDFs to bring your own research into openEO. And then provide some more information on this Apex framework to which I alluded to earlier on. So let's go to the community examples. Yes. And the one I want to discuss is the statistical data filling. So I've often talked about Sentinel-2 data and that you want to, for instance, to do your cloud masking, take the clouds away. Now, if you're doing time-bound analysis and analyzing trends, then of course, you might not want to have such gaps in your final result. And one thing which we often see that's being done is the use of statistical data filling. Now we have a standard standard interpolation function, as you've seen in yesterday's workshop within openEO pre-installed, made available on the openEO backend, but maybe you want to use your own more dedicated, more correct statistical data filling. And in this notebook on lowless regression, statistical data fill, let's go back. You can even take a look here. If we go to statistical data fill, we can see we want to use lowless regression in openEO, where we'll do some aggregate temporal. We'll use apply dimension for using our UDF, and it's on Sentinel-5 data. So that's very different data than the one we've seen so far. So far, we've been looking into Earth's observation data, more as two-dimensional images of Sentinel-2 and Sentinel-1. Sentinel-5 is the satellite where we actually measure gases, presence of gases such as methane and so forth. Now, I think the most interesting part of this notebook is that we're again going to use UDF for doing data post-processing in a very simple, intuitive way. So once more, we see this familiar pattern coming up. We authenticate. Then we want to get nitrogen dioxide information of our Sentinel-5P collection for a particular temporal and spatial area. Now, what we're going to do is we're going to use again aggregate temporal period to get daily composites of this data. You might have a couple of observations per day for this satellite, and we want to aggregate this. Now, if we were going to take a sneak peek at the output, we see in red is the observed data. And there might be some days in our analysis for which we lack our data. You might want a more continuous output result to analyze trends instead of raw data. One option to do there is to make use of specific statistical interpolation. And here we'll integrate the use of Loess interpolation to fill these non-values. And in the examples I've showed before, I've always incorporated this UDF from a separate file. But for very small UDFs, you can even do this from within your actual notebook. So remember, I think this idea for me to showcase this notebook was triggered by our earlier discussion on how does openEO actually know what to do with your UDF. And I explained to you, well, it gets translated to a string. You can also explicitly just give your code as a string to openEO, and it will also know what to do. So beforehand, we always pass the file, and what openEO does for you is just put it in a string and send it along. But you can also simply use a code from within a string. So what do we see here? Again, this definition of this apply data cube, which has access, has access to context values. You get your input cube as a data array. You see that we're using some X-ray functionality for applying the lowless functionality, which we defined here. So what's lowless going to do? It's going to check, do we have non-values? Which are the non-values? If so, we're going to do a lowless interpolation to interpolate the non-values. More information on this lowest method. You can check the stats model functions at the stats model package to find more information on this lowest interpolation. And once we have our output data, again, we're going to just simply create an output X-ray. Our result cube is an X-ray cube with time-bound output coordinates. Now, in the examples which I showed before, we were always using vision-based either algorithms for smoothing or for machine learning interpolation. Now, in this case, we have very different data. We have this gas absorption data for which we're going to create a timeline. And what you can do is, if you go to instead of using this earlier apply neighborhood, where we had to pass a certain size, spatial size, on which patches we actually wanted to apply our UDF. In this case, we now have an openEO cube, which contains X and Y information and time axis. And this time axis contains, along this time axis, we have values for observation, but we also have non-values if there wasn't any observation on that day. And we want to interpolate along this time dimension. So this is also something enabled by standard openEO functionality. So you can say, well, do an apply dimension and apply it along my time dimension. What do I need to apply? Well, my UDF. And then you can execute this batch job. You see here in 8 minutes time, we can get the output and we can see raw input. You see we have some missing points, some non-information. And then we have an interpolated end result, which is smoother as the output. Here I'm also not claiming that this interpolation is a more superior or a better result, but we showcase here that we can also use dedicated statistical processing from a different package and apply it along our temporal dimension. And here we, I think, touch on a second very important point on what to do with these UDFs and how to use them. If you go to the standard openEO documentation, I think I actually had it open, openEO.org. It provides some additional information on how we can apply these different UDFs. So, yes, we know this about openEO. We want to have some more information. Oops, am I on the wrong one? Yes. User documentation. Let's go to UDFs. So, okay, need to quickly browse to the correct page. Python. Yes. Oop. Stop sharing. There we go. See. Yeah. So if you go to openEO.org, we also have documentation on all available processes. So if you have a standardized workflow outside of openEO, we can take a look at the operations, for instance, the masking operations, which you can use in openEO. You can see the various math operations which are available, date and time operations which are available. And an interesting one, if you want to work with UDFs, is a cubes one. Because a cubes one lists all the various operations which are available on openEO data cubes. And here are a couple of interesting ones if you want to use a UDF. So first we've seen apply neighborhood. And if you take a look at the information here, what does apply neighborhood do? It applies a local process to a data cube. So, and if we check what it needs to have in order to operate it, we need to give it some input data cube. And we give it an openEO process graph. What does it actually need to do? This can be calculating the max, or it can be a UDF. So we can say process equals UDF when we apply this neighborhood. And that's what we've seen in these previous examples, where we use this apply neighborhood in order to perform our UDF operation, because we need this localized information for this convolutional neural network where we're sliding along this window across our data cube. Now, you'll see some examples, I think, in the if you dig a bit deeper in the VITO ecosystem EO processing code, you'll see that we're not using apply neighborhood there, but we're using apply. This might be confusing at the start, but the reason for this is this UDF of a CatBoost model. CatBoost are per pixel predictions. So it doesn't need a local environment in order to perform the model inference. It just needs single pixel information. So we checked which openEO process is most applicable to it. And we saw, okay, we can use openEO.apply, datacube.apply. And again, we give some input data cube, and we give a process graph, which in this case can be a UDF. And then we see it will apply a process to each value in data cube. In contrast, the process applied to each pixel in our neighborhood. This will perform it on each pixel in the data cube. So all the pixels, if we want to do all the pixels separately, we can use apply. Now in the example I now showed, we use apply dimension. Why is that? Well, we don't want to perform it over all the pixels in our data cube. We want to spatially perform it across our band, but we don't want to apply this UDF along a temporal dimension because we need the full temporal dimension for the interpolation. So then you can use apply dimension. It applies a process on all values along a dimension in the data cube. So we can take another look at this community example. What are we specifically doing here? We're here using apply dimension. We say apply this UDF along our temporal dimension, and here is my UDF. And then you know that openEO will process each pixel and each time process the full temporal dimension. If you would have used apply, you would go per pixel in the spatial dimension, but also in the temporal dimension. So second, I think, step, once you've transformed your UDF, and you know, okay, this is something I want to run in openEO, and it's now openEO compatible, you do need to consider how am I going to tell openEO how to perform my operation. Because what actually happens with this UDF concept is you write your own custom code, you put it in this UDF, but then we kind of hijack standard openEO functionality to perform this user-defined functions. And we have some standard functions, this apply dimension, this apply neighborhood, which we've seen before, which we're somewhat hijacking to actually do or to perform our custom code. So you do need to know which apply am I going to use, and these notebook examples are an excellent resource to get inspiration on what you can actually use. Another often used one, especially for a neural network inference, is reduced dimension. So let's assume you have a three-dimensional input cube, x, y, time, and you have a classification network, which works per pixel. And it takes this full temporal range, and at the end it tells you, well, this is a tree, this is water, or this is land. Well, if you perform this locally, your input cube starts three-dimensional, and your output cube is two-dimensional, because you lose this temporal information in exchange for a band dimension, in exchange for two-dimensional output, which contains values 1, 2, or 3, depending on your classification. So you reduce your data along the temporal dimension. So this is one which is also often used. So we either see apply dimension, we see apply dimension, apply neighborhood, or reduce dimension in case your data cube actually reduces during the operation. So this is the second step. If you want to bring your own work to openEO, first test it locally on an X-array, see can I get this to work, then report it into UDF, and then the final trick is just figuring out in which standard openEO process will I actually wrap this openEO UDF. This may be tricky if you're getting to know how to work with openEO, and that's why we have this vast amount of openEO community examples where you can get some inspiration and understanding of what is being used when and why. So really go through the community code, get to know how it's working, and then you can get a bit inspired. Before I move to the final subject on how you can request additional help from the openEO team, if you want to bring your work to openEO, but yeah, you think, I need some expert guidance. Are there already any questions on this final part which I presented?
I have one maybe trivial question, like for this UDF you used stats models for lowest, so there is no restriction regarding libraries that we can use. We could use like SciPy instead and do process. The most important thing, I guess, is this apply demand.
Yeah, so I think I'll post a link in this chat later on where you can actually find which dependencies are pre-installed on your openEO cloud-based backend. Mm-hmm. All these libraries you can simply use freely. The only thing you do need to check, they have a specific version, and we make sure that all our environments are stable. So if you're using the latest package release or support, if you're using something in NumPy 2.0, it might be that our packages still have NumPy 1. And so forth. And so that's one thing you do need to check. The function which I want to use is actually available in the package on my cloud-based backend. And if that package is not available, then we can start up the discussion on how we can make it available specifically for your openEO job.
Okay.
So I think then I'll move to the last subject. Let me go back to the relevant slides. So overall, we've seen, I think, on this EO habitat workflow that we have these different steps. Our data extraction, for which we can use our multi-backend job manager. Model training is something which Lori discussed during her sessions. And then we've seen how, if we now have a pre-trained model, or we have some own statistical analysis which we want to do on our Earth observation data cube, how can we actually tell openEO how to do it? Well, we use this concept of UDFs, where we write a process, an X-ray process of what we want openEO to do. And then we use some common pre-existing openEO operations such as apply kernel, apply neighborhood, or apply dimension or reduce dimension in order to run the model inference or the statistical analysis. And if you want to get more information or get a bit inspired on all the possibilities, take your time and browse a bit through the community examples or interact with us on the CDSC forum. Now, finally, I want to tackle somewhat this upscaling activity. So we've seen that openEO jobs come with a certain cost. If you have a standard, if you have a CDSC account, ESA grants you 10,000 credits each month, which you can do to perform your testing of your work. The minimum an openEO job will cost is around roughly 4 credits. So with this budget, you can run easily thousands of openEO jobs, so you can easily do your test work. However, once you want to move to a larger scale production and get large scale maps or a live service running, you might need a bigger budget. And you don't only want a bigger budget, you actually also want to make sure that your openEO code is super efficient and super optimized. Now, doing so really needs experts, and you need some experts who help you along in this process. And in order to do that, I'll need to jump a bit further. Recently, ESA released the Application Propagation Project, the APEX initiative. And the core idea of APEX is what we see in Earth observation and in this project-based way of working is that unfortunately often when new algorithms are implemented or so forth and the project ends, there's not a lot of ownership, there's no budget to maintain it, and this result gets lost. And so in APEX, we actually want to avoid this. And we want to use openEO as a tool to avoid that your results get deprecated. And how do we do this? Well, if you browse to ESA APEX, it has a GitHub repository. And we can take a look here. You see, we have here an algorithm catalog. Now, what does it contain? Here in VITO, we can see a couple of algorithms here, processing algorithms. So what does this contain? Well, it contains openEO UDPs. Don't worry, I won't go into depth with UDPs, but basically it's a parameterized version of your UDI. So if you want your work to continue and to be maintained and easily shareable with other researchers, or you want to make sure that your functionality remains operational, but you won't be able to do this within your project budget because the project budget ends, what you can do with openEO APEX is you can request openEO specialists to transform your workflow to openEO code. And then what we do is, once we've ported in openEO code, we create some testing, which will run each day to test, is this workflow still producing the same output as it did before? And in that way, you can somewhat transfer the ownership from your own workflows into towards the openEO team, which will make sure that your workflow within openEO remains functional. And that's this core idea of APEX. Now, if you want to do this, of course, there are a couple of other things in which we can help you as well within this APEX services. And I think the most interesting here one is your instantiation services. This is more if you start a new project, you can ask APEX, these are partners outside of VITO, to, for instance, help you setting up documentation portals, user forums, and so forth. But you can also have the propagation services. In these propagation services, you can request additional funding outside of your project to ESA, where you can ask for specialists of, for instance, the VITO team to integrate your existing algorithm into openEO and port it to Apex. In this way, we can make sure that your workflow produces consistent results. And if it changes or something changes or something breaks down, we as an openEO team try to fix it, and we will contact you for some scientific validation to ensure that the output is still looking as it should be looking. So we take some ownership there to ensure the continuity of your science results. Apart from that, you can also ask for support for algorithm upscaling. So let's say you've done your work and you have an openEO workflow. You say, well, now I need to run this over an entire country or entire continent or even a world map, and I don't know where to start. Also, then you can ask additional funding outside of your project funding to help to have our team help you to scale up your algorithm and to enhance your algorithm. So we'll optimize the algorithm to lower the actual credit cost and use best practices and some expert knowledge to fine-tune your algorithm. And we'll do this in a collaboration together with you. But you can also ask afterwards that we as a team help produce your land scale map, your global map, or your continental map. So this is all available through the Apex propagation service. And if you want more information, the presentations which will be shared also have this link website, which has a link to the forum on data space ecosystem information, web editor, Python client information, so everything we've visited in these 2 days. But you also have some Apex documentation information, to which I already briefly went yesterday. And here you can find much more information of the requisites on this propagation and instantiation services. So with that, I want to end at least my presentation part and leave some room for questions and discussions. So I already see a raised hand by TNL.
Yeah, hello, Hans. I'm Tiana. We haven't met, or maybe you were at very beginning yesterday. I'm with the flu and I couldn't join you yesterday. But today I'm better. I was like following whole day, and I'm coordinating this project for the biosense team. And maybe just I'm gonna ask you something and take a note that I'm an ecologist experiencing species distribution modeling mainly, and I do some spatial modeling and so on. But then what I would like to ask you from organization point of view, could you sit and talk with the team who is coming to VITO and somehow give us a view how you organize this job? Because what I understood is that not everyone are doing everything. As Lori mentioned, the colleague is doing this extraction. This one is focused on this. So maybe to organize our team in the same way, so the people can follow everything, but some of them should be dedicated their efforts to one part of this job, and others or some. So that's why I'm going to ask Helene to have one more colleague to join who will help in planning and scaling the fieldwork effort. On the other hand, I was talking with Marcel today, like discussing a bit about this change of state of the habitats type based on the NDVI. So like one person can be focused on that. So, and then develop later indexes and indicators and so on, because the idea of the project itself is like is to get this knowledge transfer, but also to be capable later to do this monitoring of habitat types and like follow what's going on in nature. And most of the people who are from our remote sensing team are those who are doing this crop type classification for years. So there are skills, but let's also get some structure from your part how to organize our people. Does it have a sense?
Yeah, definitely. So I think I'll be there. I'll definitely be there at the end of March. So then we can easily discuss and sit together as well. The way we internally structure it here, or the way you can envision our different roles, is you have the team of Marcel and Lori, which is really application, and they do a lot of science to figure out what are the best ways of doing it, what's the best way to do our classification, what's the best way to create maps. They have our team, the openEO team, which provide them tooling on how to reach their goals. And what we want to take away from this application team is a difficulty in thinking on the technical side of how to do it. So we guide them in the use of openEO, and we develop also openEO a bit hand in hand. So usually if we collaborate with partners, we operate in a similar way, that we work, for instance, with application specialists and so forth, and we try to help onboard your science into the openEO framework in a way that doesn't give you any headaches. And then once we have onboarded it, we add some tooling to ensure that we get consistent results. So we try to split up a bit the technical part and the scientific part. And at this interface, we try to connect. So we try to connect in order to get validation is the output still correct? How do you expect this output would look like, and so forth? How should it work? What type of new exciting models do you want to use? And then we try to technically realize it. So that's a bit the interface we use here internally. And that's, I think, the same interface we'll need to use with external partners.
Okay, that's quite important, because then later on, like this year, we can better plan the visits, not just BIOS to VITO, but also VITO to BIOS. So then when people from VITO come here, people can just, I think it's going to be easier for most, but it's going to be easier for them to work when someone is physically here, because of the, I guess like that is my impression. So let's talk about it, and I'm happy that we had this before this coming visit to VITO. So there's a lot to discuss that week, and thank you for the great job you did in the last 2 days, and to Lori and to everyone else who were involved in preparing this workshop for us. So that's all for me.
Okay, thank you. I see another hand raised by Milos.
Yes, thank you once again for yesterday and today. Related to this Apex, your last topic, how do you make selection of the projects that will be like supported?
Yeah, so actually that's something we don't do. So we are a partner in Apex, and ESA commissioners actually decide
but do you know how do they do it? Like some.
Yeah. So you have this, I don't know if you heard of the ESA Network of Resources framework or ever used it?
No, actually no.
I'll actually browse through it. So if you have a ESA project, ESA resources,